everyone. Today we're going to continue from the last class. I explained about latent semantic indexing. So in this and next episodes, we're going to cover how to apply this latent semantic indexing to presidential inaugural addresses. Today we're going to talk about pre-processing the documents for this particular natural language processing technique. Okay. So let's open up here what we call code. And I'm going to use first the data. It is from the University of California, Santa Barbara as a project. And it's also on Kaggle. So let me just show you. So there's this American presidency project. It's on the researchers at UC. And it contains the date and the words it has and the inaugural address. So this can be just cut and pasted like all this, and then put in a text file and save it. You can do it yourself. There are only like 59 of them. Or here's the Kaggle data that basically did the job for you, right? So we're going to use the data. If you download it, it's just a zip file, and then here I put it in my speech folder, and then here basically have that folder. Okay, so those are the text documents that we're going to process. So how do we do this? First, let's TensorFlow, and then the NLTK, natural language processing, to use the packages to clean up the data. And now it's done. And import all the libraries. There are a whole bunch of them. NLTK is probably one of the important ones. And let's mount our drive so I can access my speech, the text files, the presidential addresses, and then process multiple files here. So here is, I'm changing the directory and give the path directory to the speech directory in my Google Colab. So this is my address of that. Okay, and now that I changed it, you can see that it's content mount my drive Google Colab notebooks. So you can have your own. If you want to know, this is how you find out where your location is. And then here are the way to read in automatically in your Google Drive, the speech directory, pick all the text files. So for each text file that ends with txt, and process file one by one and put it in the dictionary that you have here. Okay. So first it opens the file and read it. So this is how you do it. So for all my files. And then I'm converting to the lowercase. So they are capitalized characters and not just doing it. And then I remove all the unnecessary punctuation that doesn't count much for the meaning. And then the stop words. I use the common English stop words to remove that. Then we have done this in our earlier NLP examples, so I'm not going to be spending too much time, but just all the tokenization, the alphanumeric, remove all that's not alphabetic, and remove the short tokens. And here's a trick that keep only the nouns. So here there's an NLTK position tag, and is it a noun? Then keep it, otherwise not. Okay. And then save that in a dictionary of my set, and let's run it. So it will process documents. Oops. I don't think it will be doing the right change directory. Okay, so here, all the speeches have been processed. So if you look at the dictionary, influence, anxiety, all this here, there are 59 documents, there are 59 inaugural addresses. So that we have. And then to generate the list of the vocabularies and the document matrix. So there are total 18,000 tokens, but they're repetitive. So I want to keep only the frequently used tokens. So here's this counter. We have done this before in the early NLP episodes. We have 4,893 unique words, and some of them appear repeat many times across the document. And even within a document, you can obviously see country, nation, kind of word is going to be used a lot in a given inaugural address. So I want the minimum occurrence to be 20, so not too rare, so only once used, but I'm going to just the minimum. So there are 154 unique words that appeared more than 20 times across the 59 documents. So I just keep them as my vocabulary list and I save it. Okay. Then I can create the one-hot encoding vector. We've done it before. So there's the rows are the vocabulary 154, and then the 59 documents, and it's a 1 or 0 if the word is used in a particular document. Okay. So here we have it. So, and here is the what the binary matrix looks like. 154 rows and 59 columns. And then you can, of course, look at the distributions here, what words are most frequently used, and search the top 10 of them, then plot it and save it, save the figure, so that it's, what would that be? So here, so you have the figure here, isn't it? You click it. And then you can also look at the distribution of it and the pairwise cosine across documents and save it. The pairwise cosine documents, for example, the similarity will give you for the speech 1 to 59, how do they each other correlate? For example. You can do all the things. And this is basically concludes the cleaning up the data. And eventually out of this, the most important thing will be the binary file, isn't it? The speech binary file. This one is what we will use for the latent semantic indexing. Okay. All right. Thank you for watching this episode.